G'day guys, John here. We're going to be doing a full scan of this race car. I've got Dan here from 3D Digital Garage. Welcome to Car Design Workshop.
G'day, Dr. Kev here. Now you've seen John before in previous videos, but it's great to know that he's looking to help out this channel a lot more in the future. One of the guys he's been helping out is AJ, and when AJ is not looking after half the cars in Northern, he likes to go fast. And the car that we did a scan of is one that we're looking to get a bit more speed from. So before we run through the scanning process with Dan, let's get a look of AJ in his office.
So we're here today to do a scan on this 1994 Oldsmobile drag car. We've brought in the experts. Dan, we've got you in today. What are we going to do?
So today we are going to take a full body scan of this car, all over the top. Then we're going to get it up on the hoist, do the underside, merge all those scans, and we'll have a complete scan ready for some aero testing.
And what are some of the difficulties with trying to scan something this big, say compared to a piston or something of that size?
Something that you can do on the bench. The volume, the sheer volume of this, getting a complete scan where all of the data is nicely merged together. We have some good scanners in our range. We use for this one, we'd use the Nimble Track or the Track Scan Sharp, which is a tracking scanner. Place a few markers around the car, and we can carry a volume all the way around and track that scan and lock all the data together with a accuracy of about 0.06 millimeters.
That's pretty fine.
That is.
And how big, so we've got obviously a car is fairly large being in the automotive sector, but how big can you actually go with that kind of scanner?
Well, these scanners, the Nimble Track's great for 3.2 meters in one sitting, but we can extend that volume with a few markers. That little beast, I've done some 15-meter trailers before. Then we have the Track Scan Sharp range, and that's good for up to 8.5 meters. But once again, you can extend that volume quite substantially.
Yeah. Now we keep talking about markers. Why are the markers so important?
The tracker can see the object by itself within its field of view up to 8.5 meters for the Track Scan Sharp. If we want to extend that volume, the tracker needs to see some markers so that it knows where it's at, and it can glue all those bits of scan data together.
Yeah, so it needs that reference point because you're not just scanning from one point. We've got to move that around the car. And
Indeed.
that's
if we had to scan something just within that 8.5 meter volume, from that one point of view, we don't need any markers at all, as long as the part doesn't move.
Now on this car, we really want to look at the aerodynamics, which is what we're going to do after this, but we're going to have to scan the underside of the car. So we're going to have to effectively do two scans. What are some of the complications with doing that?
So some of the challenges of merging two different lots of scan data from two different scan sessions, mind you, is the vehicle as it sits here on the ground isn't necessarily going to be in the same geometric shape as when it's up on a hoist.
Yeah, we're going to have suspension movement. So
suspension movement, depending on how the jacks are on the hoist legs themselves, it might actually put some twist into the frame.
Yep.
So essentially, scan 1 and scan 2 are of two different things according to the scan data.
Yeah. So we got to try and merge them, cut them, and put them all together as one to get something as accurate as we can make it within the bounds of what we can do.
Indeed, indeed. The best way of doing that is taking some good overlapping scan data between the two sessions. And in some situations, we can actually use the markers that we placed in scan 1. If we keep them in scan 2, we can actually splice those markers together to have a more accurate alignment of the two scans.
Awesome.
Yeah.
Now, one of the advantages that we also have on this is once we've got the scan and we use it as our base, if we want to make changes in the CAD, we can use that as our base and do that afterwards, which can really help with making theoretical changes before we actually have to make any parts. So,
oh, indeed. You've got once we've completed a full body scan, you've got a digital clone sitting on your computer ready for future development.
Yeah.
Whether it be just testing for what you've already got or modifying the vehicle and then doing digital testing once again,
Yeah.
like I say, yeah.
And that can be a cost saving. So while there is some money when scanning the car initially, in terms of that iterative process on designing a part, you could actually save that money just in not physically making parts and do that work digitally.
Yeah, indeed, for sure.
So one of the big advantages that I find with the scanning is reverse engineering of parts and then restoration of older parts, some of the stuff that we can't get anymore. Do you find that as well, that just giving access to components that don't exist or you can't buy anymore?
Oh, indeed, that's a very big part of my business is scanning obsolete parts. As long as we've got a good reference, and by all means, it can even be damaged or worn given the age.
Yep.
And that's pretty common. But with the scan data and some reverse engineering software, we've got some good techniques for bringing back the original geometry. And then you have manufacturing techniques these days. We can go from machining, 3D printing, and so much more.
And the scans are so good now that you're actually getting to the point that we can scan something and literally just send that to a 3D printer and print it as it is.
In some situations, yeah. Probably one of the biggest misconceptions is that scan data is ready for manufacturing. When it comes to 3D printing, it can be if the scan data is complete. Some items, there's hidden geometry and hidden data that we have to then manipulate in a CAD software to close the mesh out ready for printing. But the accuracy and the quality of the scan data, a lot of people are going straight to 3D print these days for sure.
Yeah. And we're seeing metal printing now becoming more and more common. I know myself, I'm using it like crazy at the moment, but that technology is just coming in leaps and bounds.
Indeed. It helps us have parts manufactured that just normal techniques just couldn't. Geez, I think there's even people out there 3D printing pistons and some high tech, high performance engine parts. The technology is definitely advancing very quickly.
And what are some of the differences in the scanners that you use yourself?
I run a few different versions. We've got handheld scanners where you've got to place some markers within the scanner's field of view. And the cameras are quite close on those little handheld scanners. So you've got to have markers quite close. Yeah. So to do a whole car like this with a little handheld scanner, you might have hundreds, almost thousands worth of markers on there. Those handheld scanners are great for getting into real tight areas like inside the engine bay where the larger tracker scanners just physically can't get.
Yeah.
And great for quick setup. If you're doing a bench part, a couple of markers on it and you're done. But if you've got larger parts, we have our tracking scanners. And we can scan anything within the tracker's volume without any markers as long as nothing moves. But if we want to extend that volume or have a part that's moving around, let's say there's a part that we have to lift it up with a crane to get the underside of it. If we place a few markers on that part can be moving around and our scan data is still perfectly locked.
Yeah. So that's making sure you've got the right scanner for the job that you're doing. So,
yeah, indeed.
Yeah. So for someone like myself, I've got a handheld scanner and I get to do some great work with it. But for something like this, I've got to get someone like you in because the budget from, your handheld to the larger scanners can be quite big. Some of the scanners we're talking up to, $200,000.
Yeah, indeed. And geez, you can get some really cheap scanners out there these days. And they're okay for doing your small hobbyist stuff. But if you want great accuracy and repeat consistency with the scan data, you got to spend that a little bit more, unfortunately.
Yeah.
But metrology grade scanners is where we're at.
Yep. And what's your opinion on people scanning with their phones? That's a good response.
Yeah. Look, budget's a big thing. Not everybody's got money to spend, 10 to 20, 30, 40,000 or even in the hundreds of thousands for a scanner. So everybody wants to start somewhere.
Yeah.
By all means, I did it myself. I picked up a phone when I first thought I want to get into scanning, tried it out. It captured something.
Yeah.
But in the engineering trade, it's just not good enough. So
yep.
Into the metrology grade scanners for me it was.
And there's just so much to learn, isn't there? So you can start at that level and it's not just the scanner itself, it's the actual process. It's like all things, it's all about the setup. So you can have the best scanner in the world, but if you get the setup wrong, that's something you have to learn with experience on the right way of doing things.
By all means, even with our top end equipment, humans can still make mistakes.
So even something as simple as choosing the right place to reference something. So I know on a cylinder head, I don't want to start in the middle of the cylinder head. I want to start at one end and work my way across. I imagine on something like this, it's exactly the same.
On a larger part like this, if we're using the small handheld scanners with lots and lots of markers, we can get an accumulation of error. So we've got to be very strategic with how we capture our markers. With accumulation of error, if you started on one face, worked yourself all the way around the car, there's a good chance by the time you get back to that starting point, there's been an accumulation of error all the way around that vehicle. One method that I've come up with that works great is start from the center and the top of the vehicle and work your way down and around the vehicle. That gives you a nice center origin to work with.
Yeah.
A little bit more stable with the marker collection on that one.
Right.
Yep.
So it's important to have a bit of a plan before you start getting into it.
It is. Trial and error is a good tool. And yeah, just getting out there and practicing with it for sure.
And how often do you think you're actually scanning full cars? I know this is my first one with you, but I feel like it's something I'm probably going to do more. Have you done many cars?
Yeah, I probably do 1 to 2 cars a week.
Oh, wow. Okay.
Yeah, there's a lot of call out there for it, but from so many different aspects as well.
Yeah.
I mean, this is for performance for aero testing. I've got a client that's I've done a lot of scans for him and modeling for concept.
Yeah.
He's trying to build a nice hot rod, and he's got a picture in his head, but he's got to relay that information to his builder.
Yep.
And the best way to do that is with 3D modeling.
Yeah. Because I guess that really goes across all forms of automotive work, whether you're building bull bars or you're doing air intakes or you want to do a set of mud guards or anything automotive, that's coming up. When a new car comes out, there's nothing more advantageous than having that data ready to go and just getting that scan and getting that information straight away, rather than sitting with a tape measure and trying to measure this and trying to measure that. Just one day full scan and you've got that for whatever products that you want to come up with your line.
Oh, indeed. And there's nothing more powerful than seeing a product that you've designed fitted on the car before you've even spent any money.
Yeah.
If you've got a scan of that car, you've got a digital clone on your computer, you can model up your design, whether it's wheel arches, wheel flares or bull bars, and you can see how it's going to look on that scaled model on your computer screen, sure. But by means, you can even 3D print your concept on the vehicle and have that on display. You can even 3D print full size concepts. Yeah. If you wanted to, let's say, modify the snorkel on this vehicle, we could 3D print a concept, fit it on there, see how it looks, do some aero testing, and then go into manufacture.
Yeah, because even the plastic printers, they're just getting bigger and bigger. So and even coming down in price. It's crazy that you can go onto websites these days and put your model up and get a quote with shipping and everything ready to go.
Indeed.
And just the materials is the broadness of what's available now. We've got from PLA all the way to carbon fiber and forced materials that nearly have the strength of aluminium. It's really impressive, even just the plastic area.
Indeed. There's even companies out there 3D printing in stainless steel and titanium. I had a couple of car badges 3D printed in stainless steel, polished them up. I even had to weld some parts on them. Yeah. The weldability was still fine as well.
I've been amazed with the weldability. Yeah, I've got a few parts done myself and I'm really been impressed with it. So especially on the exhaust side, it's made flanges and testing parts just so much more readily available and getting something fast. The time, I think, is the most impressive thing, let alone just the quality. For sure.
Sending a part to a machine shop for it to go through the process of machining, and instead of doing that, go to 3D print for concept at least. You can have stuff 3D printed overnight. Everyone's shut the doors and gone home, but the machine's still working. So you wake up in the morning, you got your part ready to go.
Perfect.
In some situations.
All right. Well, thank you for your time, Dan. And
no worries.
I'm looking forward to seeing the results.
For sure, man. Have a good day.
We've got AJ here, and we're going to have AJ tell us a little about the car.
It's a 1994 Oldsmobile Cutlass. It was built in the US, carbon fiber front, steel roof and quarters. It's a drag car. We race in super stock. Small block 335 cubic inch engine, 5-speed clutchless transmission, and a diff, and away we go.
And what are we hoping for quarter mile wise?
I think the class record at the moment is about 802. I think, we would like to be somewhere close to the handicap, which was the class record. That's sort of where you're chasing. You'd always like to anticipate you could maybe go a little faster.
Yep.
But that's obviously set by the fastest guy in the country. So in B gas, I actually think the record's about 743. So
right.
If we could go into the sevens, we'd tick every box we've ever dreamed of. Yeah.
So we've had the engine on the dyno. We know what the engine's making power-wise.
Yep.
We've had the shocks checked. They've been on a shock dyno.
Yep.
But aerodynamically, we don't know where this car's at.
100%. You got to look for areas, don't you?
Yeah.
You got to look at everything,
Yep.
And I think, we can only, we're naturally aspirated. We can't just turn the boost up. We can only make what we make, you know. The suspension is what it is. So, you know, if there's gains to be had in the aero package, you got to look everywhere in this sport, I reckon, anyway. Yeah.
So today we're getting a full scan of this car. We're going to take that, turn that into CAD, and then we're going to look at that in a bit of CFD and see how the car's actually performing.
Yep.
We're hoping to maybe get some of the original data from back in 1994 if we can talk to the right people, which would be great to look at.
Yeah.
What have you thought of the scans so far? What's been your take?
I don't know, sci-fi is the right word, you know,
Sci-fi, yeah.
It's really cool, you know, like I come from you know, this is all new. This is so cool, you know. Someone dreamt this up and made it out of clay in the 90s.
Yep.
To be able to see Dan come and scan the car, you know, and put it onto a computer screen, you know, it's just amazingly cool.
Yeah.
The process, you know, I'd have no clue how to even turn the computer on to make the process happen, but you know, it's a really cool process. It's amazingly cool.
Yeah.
Yeah.
And the first thing you said was, can we turn that into an RC body?
Absolutely. Yeah, absolutely. Surely we can do that from this data.
It'll make your kids happy.
Yeah, 100%, 100%.
So we've got a bit of a break between racing. So we're looking at some of the improvements on the car. We'll get this CFD going and see what we can find, but how keen are we to get straight into testing?
If you ask me, we'll test out the front in the street. I think as soon as we can, you know, like any form of testing, like you say, we know what the engine's doing, we know what the shocks are doing, we know lots of what the car's doing. Anything to do a bit more testing, I'd do it tomorrow if I could.
Going racing's all about ticking every box, so hopefully we
100%.
can get that box ticked and we can move forward from there.
100%. Yeah.
Awesome.
Cool as.
Okay, so we've heard from AJ and we've heard from Dan. While I'm not an aero guy, I'm actually really looking forward to the results. I do a bit of scanning myself, but I've definitely haven't done anything on this size. So looking forward to seeing what Dan comes up with. Looking forward to seeing what the CFD results are. It's another opportunity to use. Very curious to know what you guys are doing with scanners. They're becoming more and more popular. So if you've got something to comment, please put it in the comment section. Other than that, I hope you've enjoyed this video. We'll see you next time.
While we had Dan up in Northam, we also took the opportunity to have him scan an Austin Healey. Now this is a little bit more relevant for Project 171, and we're going to be seeing this scan turn up in a later video on the channel. Unlike the drag car, we weren't that interested in the underbody of the Healey, so this was a much faster scan. It also helped that the car is quite a bit smaller. Now a while ago we actually started a Patreon page for this channel, and we occasionally post there about videos that are upcoming and work that we're doing on the car. And when we get an opportunity, also put up some of the files that might be relevant to people if they want to have a look at things. So if you've been enjoying this channel and want to support it further by being a paid member on Patreon, we really appreciate your support. We want to keep the bulk of the content of what we're doing freely available to anyone, but the Patreon gives us an opportunity to put a few extras there for those that are extra keen. So if you are a paid member on Patreon, we will make a decimated model, so a model of the scan where we've reduced the triangle count a little bit so that it's a bit easier to load. We'll make that available to paid Patreon members. It was definitely great to see Dan in action with both of these vehicles and show us through some of the techniques that he's developed over years of scanning. Now we're extra lucky that Dan didn't charge anything for this. He didn't even ask us to put any advertisements for his business in this video. But I know both Jon and I were incredibly impressed with his professionalism, and we're hoping that as we move forward with what we're doing on Car Design Workshop and the work that Jon's doing in his consultancy, that Dan's going to be somebody we draw upon, I think, increasingly as we're going through this process.